So, last week we introduced, talking about translating these linear programming problems, and if you can remember this one, we talked about Jerry could only work, he could either be a tutor, he could either tutor or he could be a delivery driver, and he wants to maximize his earnings. So step one was figure out what we're trying to optimize, and well, we're trying to maximize earnings. There's going to be a something x plus a something y. The only numbers dealing with earning were the $10 for x and the $12 for y. So after you figure out once you establish what you're trying to optimize, then you need to talk about what x and y equal. And x equaled the number of hours tutoring, and then y equaled the number of hours delivering. Okay. Now we need that so that we can look at our restrictions. First, he wants to work no more than 20 hours a week. So I'm going to say x plus y is less than or equal to 20. And since x and y are hours, the 20 is hours, that's fine. And he wants to spend at least 3 hours, in between 3 and 8 hours tutoring. So that means x is in between 3 and 8. Then we had our stupid reasons, which were x is greater than or equal to 0, and y is greater than or equal to 0. And I put a little brace around it, and then we went on to the next question. Well, now we need to talk about actually finishing the answer. And so here's what finishing the answer looks like. First, it's going to require some graph paper. So I've got graph paper. The only thing also I'd like you to notice, I think I can get by with this. No, I had to go down. I should have left it at 20. Yeah. So, here's your job. We have to graph this system of inequalities. It's going to find a feasible region. We're going to find the corner points, or the boundary points, plug them into our objective function, and that's how we find our answer. We've done that, we just haven't done it with this particular problem, so that's what we're going to do. So for this problem, I want to graph. I don't like graphing x plus y less than or equal to 20. I like it in slope-intercept form. So when I get y by itself, this is going to be y is less than or equal to a negative x plus 20, which means you got a y-intercept of 20 and you have a slope of negative 1. So I get to draw all of this, and I draw my dots, connect all my dots. This says y is less than, so that means I'm shading this way. So I've got I'm looking at this triangle. This statement, it says x is in between 3 and 8. Well, anytime you see a letter in between two numbers, I want you to think of this. I want you to graph x equals 3 and x equals 8. X equals 3 and x equals 8, those are both vertical lines. So here is x equals 8. Here is x equals 3. And we're shading in between. And then combined with our stupid reasons, we're in the top, we're in this first quadrant, we're down here, or we're in between here, and we end up with this is our feasible region. And as feasible regions go, this is about as simple as it gets. Okay. Once you identify your feasible region, you need to come up with the boundary points. So you need to come up with these corners. So we've got this corner, which is 3, 0. We've got this corner, which is 8, 0. We've got this corner, which ends up being 3, 17. And our last corner ends up being 8, 12. And your job is to, in this case, maximize this. So if I have, let's see, well, that did not work. It didn't make it in the basket. So if I plug in, let's say that's going to give us 10 times 3 plus 12 times 0, that's going to give me 30. I plug the 8 in, I get 10 times 8 plus 12 times 0. That's going to give me 80. If I do 10 times 3 plus 12 times 17, that gives me, I'm going to cheat because I've already worked this one out. It gives me 234. 234. And then I get 10 times 8 plus 12 times 12 for 224. And so my job is, which of these is, there's two questions that are asked. One question is, what's the maximum earnings? Well, that's easy. That's just the biggest number here. So that's this thing. The other question is, what should he do to earn the maximum? And what he should do has to do with this coordinate. So that means he should tutor 3 hours and deliver for 17 hours. And that's going to give him his maximum earnings. So let's refresh our memory about the Algebra 2 quiz with some computation problems and some graphing problems. So we've got, we read this, we did this last week. If you get your notes out, we're going to basically summarize how we got our constraints and our objective function. They talk about the graphing, the computations where problems are worth 6 points, the graphing problems are worth 10 points. You've got a finite amount of time, and you have a finite number of problems that you can answer. So, first thing you always do is, what are you trying to optimize? And this time we're trying to maximize score. And it's going to be something x plus something y. Let's say there was a 6, and there was a 10. And once you write like 6x plus 10y, then we have enough information. We know that what x is going to equal and what y is going to equal. X is going to equal the number of computational questions, and y is going to equal the number of graphing questions. And that's going to help us come up with our equations. As far as our restrictions go, well, if we've only got 12 problems, well, that's pretty easy to deal with. X plus y have to be less than or equal to 12. This inequality makes sense because this is talking about number of questions. X and y are talking about number of questions. I don't need to convert anything. The next one, well, we've got to do a little work. It says we have 40 minutes. So if I've only got 40 minutes,
Sorry, on the top, what does it say that x equals?
a number of computational questions. So, and then y is going to be the number of graphing questions. So to convert things to minutes, you have to think, well, it takes 2 minutes to do a graphing problem, and it takes 4 minutes to do 2 minutes to do a computational problem. It takes you 4 minutes to do a graphing problem. Now we're going to put in what I'm going to call my stupid reasons. And my stupid reasons are x is greater than or equal to 0, and y is greater than or equal to 0, because we can't have negative questions. And this is where we stopped on Friday. We just translate, right? Now, let's move on. Okay. So now let's see what this looks like. Now, we've got to finish the question. So the way you finish the question is graph these constraints. It's going to create a shaded region, and then find our boundary points, plug them into this thing. So, let's see. One thing we know, since we're only dealing in the first quadrant, x is greater than 0, y is greater than 0. I'm only looking here. I only like graphing when it's y by itself. So for this, I'm going to convert this to be y is less than or equal to negative x plus 12. I'm going to convert this one to say that y is less than or equal to a negative 1/2 x plus 10. And I can cheat a little bit since make my picture look a little bit better. So I'm going to graph the blue line. It says start at 12 and go down 1 over 1. Imagine that was a straight line, and we are shading down. Next up, the green line says we're going to start at 10, and we're going to go down 1 over 2, down 1 over 2, down 1 over 2. And I'm going to draw my line. And I'm going to shade down. Now, this combined with, x greater than 0, y greater than 0, this is my region. I'll draw that. Now our job is, once we've identified our feasible region, we are going to list all of our coordinates, all the boundary points. So we get a boundary point of 0, 0. This is a boundary point of 0, 10. This is a boundary point of 12, 0. And this is a boundary point of, looks like 4, 8. So now that I've got my boundary points, now I'm going to look at my objective function, which is this thing, 6x plus 10y, and compute. If I plug 0, 0, well, I guess it makes sense if you don't answer any questions, your score is 0. If I only answer graphing questions, well, that's going to give us 6 times 0 plus 10 times 10, that gives us 100. If I only answer computational questions, it's going to give us 6 times 12 plus 10 times 0, which is going to give me 72. If I answer 4 computational and 8 graphing, well, that gives me 6 times 4 plus 10 times 8, which is going to give me 104. So to answer our question, if the question is, what's the maximum score? The maximum score is 104. But the original question was, what should he do to make a maximum score? And what the student should do to make the maximum score is answer 4 computational and 8 graphing. And even though we've not done many linear programming problems, this is typically the picture you get. They usually, pretty much every linear programming problem I've ever taught in 20 plus years, this is the general picture. I mean, sometimes they get more complicated, but this is typically what happens. All right, so this one, there's a lot more going on. And the numbers here are uglier. Do apologize for that. I would never make the number as ugly I would never make any test question, the numbers would be significantly nicer than this. But I still want to go through this problem. So we talk about the cost to run machine A and the cost to run machine B. And we spent a fair amount of time on Friday talking about the translation. We're trying to minimize operating costs, so I end up with C is equal to 2x plus 2.4y, and that tells me x is the number of hours of machine A, and y is the number of hours of machine B. And we've got 3 restrictions in this problem. We can only work 30 hours, so that means x plus y has to be less than or equal to 30 hours. I'm okay with. That's hours, that's hours, that's hours. I don't need to convert anything. I need to make at least 2080 volts, So I'll put 2080. And since this is bolts, I'm gonna have a combination of X and Y, but X and Y are hours, this is bolts. So to convert those, I have to say, well, machine A produced 240 bolts, so there's 240 here, and machine B produced 160 bolts. And kind of a similar argument I had, this was 1520, and this was our nut equation, so this was 100x plus 160y greater than 1520. This is all dealing with nuts, this is all dealing with bolts. We need our stupid restrictions, which are x is greater than.
Let's say 240x plus 160y is greater than or equal to 20. I'm just having trouble seeing the numbers.
2080. It was the same thing we did on Friday. Did you write these down from Friday?
Yeah.
It's the exact same problem from Friday.
Oh, okay.
So, which is one reason why I'm going through this pretty quickly, because like we spent, I've probably spent 10 minutes sort of talking about the translation, and I just needed it back on the board. So I got x is greater than 0, and y is greater than or equal to 0, and this is this massive, this has a lot of stuff going on. Now, to do this problem is the exact same as the previous two. I have to graph all of these. I don't like when I graph lines, I like y by itself. So that's going to make this is y is less than or equal to a negative x plus 30. Let me pull this back up, and I need to be able to count to 30. There we go. So this graph has a y-intercept of 30 and then a slope of -1. And imagine I can draw a straight line and it's less than, so it shades up. These are a little different. If I solve for y, this is going to give me y is greater than or equal to negative 3 over 2x plus 13. Subtract 240x, divide by 160. Again, I wouldn't give you something that ugly on any kind of assessment, but I don't have no problems doing it in class. So this says start at 13 and go down 3, 1, 2, 3, over 2, down 3, 1, 2, 3, over 2, down 3, over 2, down 3, over 2. Let's see, this next one is not nearly as nice. This simplifies to get negative 5 over 8x plus 9.5, which is pretty hideous. So I'm going to start at 9.5 and go down 5, 1, 2, 3, 4, 5 over 8. And I'm just going to save myself some pain and suffering and go ahead and just draw the line. I'm not going to make you do that on a test. I just wanted to give an example of what an uglier picture looks like. Both of these are shading up. That one's shading up. This one's shading up because y is bigger. We're in the first quadrant. And since we're in the first quadrant, this is our region. More complicated region here. I still need my boundary points. So if I start looking for my boundary points, see, I've got one boundary point, this is 13. This is 0, 13. This is 0, 30. This ends up being 30, 0. I had to do some algebra to figure this part out, but it ends up being 15.2, comma 0. And this one, I had to do some algebra, but it actually turns out pretty nice. It ends up being at the point 4, 7. So as ugly as this picture is, these numbers aren't super bad. That one's not pleasant. So now we plug it in. And when we plug in, we're trying to minimize cost. I get 2.2 times x plus 2.4y. That's going to give us 2 times 0 plus 2.4 times 13. And that gives us 31.2. Plug in 2 times 0 plus 2.4 times 30. That's going to give me 72. If I get 2 times 30 plus 2.4 times 0, that's going to give me 60. If I get 2 times 15.2 plus 2.4 times 0, that gives me 30.4. And if I get 2 times 4 plus 2.4 times 7, that's going to give me 24.8. And after much pain and suffering, we're trying to minimize cost. Well, the minimum cost is 24.8. What gives us the minimum cost is this coordinate, which is operate machine A for 4 hours and machine B for 7 hours. So sometimes they'll ask what's the minimum cost. Most of the time they'll say what causes it, so it has to do with this coordinate. Now, we're doing. And there's some tricks on how you graph. So we start and we are trying to maximize profit. So we go through and we say, the only thing dealing with money at all in this is we've got 975x plus 95y. I think we got that far Friday. That lets us that x is equal to the number of pounds of trail, and y is equal to the number of pounds of frontier. That may have got as far as we got in this class. I was hoping that I got to some of our restrictions, and the restrictions we have, we've only got 60 pounds of corn. So if I've only got 60 pounds of corn, that means 60 is on the right-hand side, and when I combine x and y, this is a corn line. Everything's got to be dealing with corn. This is corn. This is not corn. Right? I got to know how much corn's in x and how much corn's in y, and they tell us that. Let's say we've got in trail we've got 1 pound of corn, and in frontier we have 2 pounds of corn. We've got 120 pounds of wheat. So in trail, we've got 4 pounds of wheat. So that's going to give us 4x. And 3 pounds of wheat in the frontier. And do we have anything else? No. We've used up all our numbers, which is great. We need our stupid restrictions, which are going to be x is greater than or equal to 0, and y is greater than or equal to 0. And there we go. So now our job is to graph. Before I start graphing, I want to get y by itself. So this is going to give me y is less than or equal to a negative x plus 30. This is going to give me y is less than or equal to negative 4 over 3x plus 40. And, you know, I kind of the same thing as the other problems. But I didn't give you a convenient graph. Because if you look at this, if I want to graph, you know, y is less than negative x plus 30, ideally you'd like 30 on the y-axis. Well, I didn't give you that. Or did I? So one thing you may want to do is if I ever give you a grid, just because I give you a grid, you don't have to assume that's the origin. Since everything's just dealing in the first quadrant, I would kind of ignore these axes and the axes and just think, okay, I've got these little squares, that's going to help me count. Now, if I'm going to count, I need something to count to 30. I think my life will be easier if I count by twos. If I use this and if I treat this as the origin. If I count by twos, okay, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. That's 30. Right? I mean, if you wanted to put this as a 2 and 4, you could. But so if I count all the way up to 30. Now, this says I've got a slope of -1. So it doesn't mean you have to go down one block, down 1 over 1. It means you can go down 1 block over 1 block.
Mr. Alvis?
Yes.
Why would it be negative x instead of negative 1/2 x since we divided it by 2?
You're absolutely right. It should be negative 1/2 x. Dang it. Just checking. Good job. Good. Okay. So, down 1 over 2. Down 1 over 2, down 1 over 2. And we are shading down. All right, next up. I need to count to 40. So when I go up to 40, and I think I need it, okay, so I'm at 30, 2, 4, 6, 8, 10. Now I'm going to go down 4 over 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. I can probably. Yeah. 1, 2, 3, 4. 1, 2, 3. And then shading down. I've got my stupid reasons, which means I'm in the first quadrant. So I have this is the region I'm interested in. And now that I have my region that I'm interested in, the coordinates I'm going to check are 0, 0. I'm going to check 0, 30. I'm going to check 30, 0. And what's going to end up being the most important is this point, which is 12. So this is the point 12. And I'm counting when I have 24. Now I've got, notice if I counted by twos, I have to continue counting by twos to come up with my coordinates. Now I'm going to plug each of these things into this. When you plug in 0, 0, you get 0. When you plug in, if you plug in 0, 30, you're going to get $285. When you plug in 30, 40, you end up with $292.50. And I think when you plug in, let me make sure I have this right. When you plug this in, you end up with, this is $345. So, now, numbers aren't super nice, but could be uglier. So the kind of the main point of this problem was, if I give you a grid, sometimes you have to count by twos. No, you couldn't have counted by threes. That wouldn't have helped. That 40 would have really messed things up. But that's what you have. All right, do your homework.